Good afternoon. Today I'm going to show you how to convert a DXF file that was produced by Sonnet and convert it into a Gerber file and a drill file so that the board can be routed on a T-Tech router and can also be drilled. So you'll see this DXF file has three separate layers. The layers are a metal one, which you see is in green solid ground plane, top metal, which is some kind of a spiral antenna, and then a layer called a via one, which has four small vias which need to be created by drilling through the board and then connecting them from top to bottom. So let's have a closer look at this. You'll see that all of the areas are drawn as zero with closed polylines. That's a good thing because then the router will be able to figure out what the outside is and route around it. And if you look carefully at that, well, that looks like a polygon. Let's do a regen. Let's ID it. It shows that it's in fact a circle. It's very important for getting drills because if you have a circle, you have an entity with a center and a diameter. And the drill file is exactly the same thing, a center and a diameter. So that means that we can easily convert this into a drill file, that via layer. So let's start with the conversion. We're going to use Artwork's ASM 502 program and our Gerber viewer to produce the necessary files. So we'll start by clicking on Select DXF File, and there's the directory, there's the file we want to process, and you have to enter the units because AutoCAD's DXF does not have the units in it. So we'll click Open, and you get a little information about the file. Now we'll configure the converter. So there's a number of topics, and you just go through them. We'll start with Gerber settings, and since our DXF data is in millimeters, we'll make our Gerber in millimeters, and we'll use a format of 4.4. This is standard, this is circular, and that's standard, so we'll click OK. We don't have any text to worry about. Let's look at our translation options. The important thing here is the arc resolution. I'm going to use a very small value in degrees to get a very smooth spiral. I'm also going to make sure that I put out 274x. We don't want the D or anything else. Okay. Working directory we don't care about, file history don't care about. Continue. Now we're going to define the apertures because Gerber's an aperture-based program, and we'll create a file called spiral.apt to hold our apertures. We're going to define a round decode just in case there's any errors, and we'll just set it to 0.1 millimeter. Now we're going to create two decodes called polygon external, POEX. Those are essentially the outlines of an area that's to be filled in. Finally, we need some apertures that exactly match the diameter of the drill holes. To do that, we just simply use the function called flash circles. You see it found three different apertures. This one and this one are essentially the same, and it gave them block names, so we'll just click OK there. That's all we need to do. Save, and now we have to select our layers. So these are the three layers we want to process, and in terms of processing we're going to use the outline option, which will essentially follow the outline of those because they're already correctly drawn. They don't need to be filled. And on the via layer, the flashes will have priority over the outline, so they will be converted into flashes in the Gerber file, which is critical for getting our drill. Just run the translation. Of course it runs instantly. Now we'll view our Gerber data. So the ASM 502 converter comes with our Gerber view program, and now we're looking at three different layers. The red was our metal one, like a giant ground plane. The green is our spiral antenna, and let's zoom in here and you can see our round flashes. Now to verify that they're flashes, I'm going to turn off the other two layers. And I have these alone, and now I'm going to ID this guy. The info tells me that it's a flash. That's important. It's a symbol. It tells me exactly where it's centered, 30.5, 27.8, and it tells me the diameter. I'm going to take this information and translate it into what's called an Exelon drill file so that the T-Tech can drill a hole there of that diameter. So let's see how we'll do that. We'll go to File, Aperture, Edit Aperture. So this is our aperture table we created in the first step. These three guys are the flashes that were generated by the flash circle option. These two are the same, so we're going to use the same drill tool for these, 1 and 1. And this will use obviously a different drill tool. We can make the drill any diameter we want. I'm going to make this the same diameter as the hole. Sometimes you have a pad and the hole is smaller, in which case you would change that diameter. What we're going to create next is a drill file that has two tools. Tool 1 is 0.6 millimeters in diameter and tool 2 is 1 millimeter in diameter. So you do this first. Yeah, we want to save the changes. And now we'll go to Tools, and you see Drill, and we want Exelon. Leading zero suppression is fine. The only layer that's turned on right now is the VIA1, so that's the only layer it'll produce a drill file for, and of course the other layers don't have any drills. Let's have it report and see what it says. It says that tool 1 is this diameter and it found 2 holes, and tool 2 is 1 millimeter and it found 2 holes, and it came from these decodes. Click OK. So let's look in our directory and see what was produced, or what we care about. This via1.drill will be the file used to drive the drilling of the T-Tech. These Gerber files, metal 1, top metal, will be used to do the etching, and I suppose you don't need the via1.gerber. So that's it.